Boy, is it a hot day today, and I'm sweating like a pig. So I just came back from a medical checkup. They had to do all these sorts of tests, blood exam. They collected my urine sample, and the thing I hate about these exams and these tests is before they take your blood, you have to fast for at least for 10 hours. So I did that, and wake up 10 hours later. I ate around 11 p.m. last night. Wake up 10 hours later. And the thing about this is I had to go through an hour and a half of traffic, and by the time all of the tests are done, you're really famished. And so, I went to McDonald's and had myself a really big chicken burger. So anyway, we're in the middle of this build, and this is a Martian 3 frame. We're gonna post a build video coming up soon, but I originally planned to use an SPRacing F3 flight controller on this one because I had an extra one just lying around. But the thing is, things happen. I broke I broke that flight controller, so I had to get a new. Actually, I got two. I got an Omnibus F3 and also a Betaflight F3 flight controller. So while we're doing the build video, while we're finishing that build video and finishing the build of this one, I thought maybe I will show you how to wire not just the SPRacing F3 flight controller, but also how to wire an Omnibus F3 and a Betaflight F3 flight controller. Because when I was trying to build this, I couldn't find the resources I need immediately. So yeah, so let's just go to it. Alright, so here I have my three flight controllers lined up. This is the SPRacing F3, the Omnibus F3, and finally I have here the Betaflight F3. Now, one of the considerations I had when building my quad is I wanted to have an OSD showing up whenever I wear my goggles, and it's supposed to show me information about my battery and stuff. But the SPRacing F3, which I just had lying around as an extra flight controller, so this was readily available. However, it did not have a built-in OSD. So I had to use this Matex Systems Hub OSD to provide the OSD signal. And so this is just a basic 6 degree of freedom flight controller with 3 degrees of freedom from the accelerometer and another 3 degrees from the gyros. The other two have built-in current sensor as well as having OSD built in. And this is quite this is quite a good thing, because if having this having this basic, it's a basic flight controller, and if you have another board for your PDB and OSD, and then in my case I had another board for my 4-in-1 ESC, it really adds up to your stack and makes for a quite tight build. And in some frames your space is going to be very, very limited, so space is really a premium. So the SPRacing F3, you have 3 UARTs. You have UART3 here, I believe this is UART2, UART3, UART2, and these are the pads. This is the pads for UART1, but you can plug it in. You can also plug in through this header. Be careful that with this port, because it looks the same, but it's actually much different. It's for the I2C connectors. Now for the sorry, let's go back here. So basically you have here your 8 PWM inputs, and this is where you would connect your signal wires to. And your VTX you would connect it to either UART 1, 2, or 3. Now with the this is the Omnibus F3 board, and here you have to connect your battery here. Your ground goes out here at the bottom, and then your ESC actually has to go out from here. You have to connect your ESC as well as any of your electronic devices through here, so that it goes through the shunt resistor, and you're able to use the current sensor of this board. And then here, since the OSD is built in, obviously you have to have your camera going in here, and then your VTX going in here. So it is the camera in, this is the VTX out. You have the 5 volts and the ground. Now these are 5 volts by default. but you can change it with a jumper somewhere here. I think, let me just check out the specs. Yeah, so here you see that these are actually soldered together. This provides 5 volts to the RAM pins of your VTX and camera. Now, if you're using a camera and VTX that requires LiPo voltage or direct battery power voltage, then you would desolder this one and make sure that the right side is soldered to the center pad. So it's the center and the right one. But since I'm using a 5-volt VTX and camera, I didn't need to make any more changes to those. So yeah, and the VTX also goes up here. So it's just beside the, sorry, the camera's not focusing. So so this signal 1, 2, 3, 4 of the PWM. This is where your signal goes out to your ESCs. And then finally, this is the S-bus. You can use S-bus or PPM for this. These are the pins for your receiver. Now finally, here is the here's the Betaflight F3, and you wire your battery here, and then the ground goes here. Sorry, this is the ground, and this is the battery positive. And as you can see, there are 4 terminals if you want to hook up your ESCs directly. Then you have some more pins for your buzzer. All right, and all right, let's check out these pins. Now these pins are, again, there's the RAM pin. Sorry, if not focus, that's not focusing. So okay, so you have the RAM pin, similar to the Omnibus, and you have there the V out and then the V in. So this is where your VTX is gonna go, and this is where your camera is gonna go. Alright, so without further ado, let's go. Let's check out how to solder these 3 boards onto our quad. First, let's pre-tin our pads. We just need to tin the 4 signal wires, and I'm also gonna tin the 5 volts and ground beside the first signal pad. If you haven't tinned your wires already, you should do so as well. So now we're gonna solder the wires to the pads. I wasn't able to record how I soldered everything to the hub OSD, so I'll just show you how to wire it up later on. So the first flight controller that we have is it's a basic SPRacing F3 board. And it's just a basic board with we're not using much of their functionality. So we're basically just using it as just the flight controller, where our motor inputs from the ESC goes into, and pretty much nothing else. Most of the stuff that's happening is with the PDB board, which is where we have our VTX connected, our camera connected. That's also the one supplying our 5 volts to the flight controller board. And there's nothing fancy. But anyway, so we're gonna take this apart, and I wanted to discuss a couple of things about the Omnibus F3 board, which we are going to replace it with. Now, this makes our stack a lot more compact, but with a lot more added complexities. So see, this Omnibus F3 board has a what do you call this? A current sensor. So instead of just putting in supplying it with just 5 volts or power supply from the PDB, we actually have to wire our battery directly here, and then connect all of our devices in series to this flight controller going out here, and then finally terminating at the ground connection here at the bottom. So basically, this is our battery positive, and then this goes out to the ESC, and whatever device we have connected to it, it has to go through there. Because the way a current sensor works is it measures everything that goes through all of the electricity that goes through it, that flows through it in series. So everything has to pass through this shunt resistor. And so I'll try to put maybe I'll try to put a useful block diagram over here when I edit this video. But yeah, so instead of using a separate PDB, this we connect our motor wires directly here to the PWM inputs, and then our receiver goes here to the S-bus ports. Now We also don't need to plug in any more 5 volts because we're already being supplied by the XT60 battery, our LiPo battery. And then finally, our VTX and camera inputs goes here. I believe camera in goes here, and then VTX goes out here. And yeah, this board also has a built-in OSD, which is configurable through Betaflight. Unlike our original setup, which has just a simple OSD, and it just shows the voltage and doesn't show the current and anything. This one, since it's integrated with the flight controller board and it has a current sensor, we are going to set this up so it displays not just the voltage but also the current, and since it also has access to the accelerometer and the gyros, we can also display like the horizon if that is something you want. As we discussed, the LiPo's positive lead is going to be connected to this the battery positive terminal, and the negative wire is going to be connected here. And what I'm thinking is we're going to connect the VCC to the PDB as well as the ground. It's also going to connect to the PDB. That way, we don't have to do anything. We don't have to make any changes to our ESC wiring, and I'm happy the way it is. So that can sit just right there, and all we have to do is wire these things together, and we will be good to go. Aside from soldering our XT60 connector to the board, we also need to solder some 14 gauge wire to the VCC and another one to the ground. And so you have both your XT60 negative lead and an extra 14 gauge wire soldered up to the ground pad of your flight controller board. Now we need to tin our PDB and attach those 14 gauge wires to the PDB and make sure everything's tightened up. And after tinning the pads for the signal wires, we also need to solder those signal wires to the flight controller board. Similar to the Omnibus F3, you also solder your XT60 connector directly to the Betaflight F3 board. A few considerations to think about when wiring your flight controller to your ESC. ESC would depend on which flight controller you're using. So when I was setting up my my SPRacing F3 and it was connected with a hub OSD, which was powering everything, I had it mounted here on the side, and the XT60, I had some XT60 wires or 14 gauge wires running to the built-in PDB of this Martian 3 frame, which since the terminals were here on the side, it was very convenient located, and I could power everything from this red PDB thing, and I could route my power to any board that I wanted to, and that is what I did with my ESC. So I mounted on a positive and a negative pad, and when I mounted my Omnibus F3 board, so definitely I didn't need the hub OSD Maytech PDB anymore. But the terminals that for the ESC were here and here at the bottom for both the positive and the ground, and it's situated at the back. So what I did was wire it here to some more positive and negative pads at the PDB. And the nice thing about that was I didn't have to wire my 4-in-1 ESC, rewire my 4-in-1 ESC anymore. And whenever I had to, if I ever had to remove my flight control, it would flip back because it was still connected by wire. So that, yeah. However, with this Betaflight F3 board, now the positive and negative terminals that are supposed to go to your ESCs are now scattered all across the board, and I didn't have any an ideal port that I could use. Maybe I could use these two, positive and negative, and pad it to a corner, or maybe I could just so at least I still don't have to remove my 4-in-1 every time I removed my flight controller, or at least if it's shrouded here, I can just when I remove my flight controller, I could just flip it on the side. So that might be a solution. Another solution might be to just go directly to the ESC. So I'm still thinking about it, but let's try, padding it, wiring it to these corner pads. So at least we'll have one positive and negative here, which connects to the positive and negative over there. All right. Another thing that you have to consider is what voltages are going to be used for your components that you're going to be wiring into this to this board. Now, if you can see, similar to the Omnibus F3, you have some. I'm not sure if that's going to be focusing well, but there you go. So similar to the Omnibus F3, you have a couple of pads here for for choosing which voltage you want for your RAM output, and the RAM output is the one that goes to your cam and VTX here. So right now it's pre-soldered to bat. So if you take your multimeter here between the A GND, A ground, and RAM, you're gonna get whatever voltage your LiPo has. So if it's a 4S, it's gonna be around 16 something if it's fully charged. But in my case, I'm still gonna be using my VTX and my camera, which both require 5-volt inputs. So I'm gonna desolder this and move it and solder it to the 5 volts. And if you are using a DSM receiver, you also need to make sure that this one is set to 3.3 volts, because that is the selector pads for these, which is where your receiver is going to. But in my case, I'm using an FrSky XM Plus receiver, so I'm going to be soldering to the 5 volts so that I get 5 volts for my receiver, which I'm going to be soldering here. Then the right, so that's the bottom of the board, and then for my individual motor signal wires, I need to solder them to these motor signal wires, and then I can just solder one of the ground signal wires from the 4-in-1 ESC to any one of these grounds, since all of these grounds should be connected together. So we need to solder some 14 gauge wires to our ESC pads, and that's going to be connected to our PDB, which is going to be powering our 4-in-1 ESC. So here we make sure that everything's lined up and solder the positive and negative to the built-in PDB. Next, after making sure everything's tight, and we need to pre-tin our pads, and then we're going to solder our receiver onto the flight controller board. Next is the signal wires from the camera and the VTX. Also, we're soldering their power lines to the RAM pins and the ground to their respective grounds. Alright, so the last thing that we're going to be wiring up is the signal wires, or the wire harness that connects the 4-in-1 ESC to the signal pads of the flight controller. Now with the SPRacing F3 as well as the Omnibus F3, the signal wires were situated right next to each other, so it was a matter of just soldering these 4 wires there and connecting it to the 4-in-1 ESC. And that was a very simple thing to do. Now, and we got away with this with really short wires for a very clean build. Now, the problem with the Betaflight F3 is that the signal wires are situated all across the flight controller board. So you have I think motor 1 is over here. You have one more over here. I think that's M4. Motor 3 is over here. Motor 2 is over here. So this short wire harness is not gonna do well. It's not gonna do at all. So thankfully I have a spare 6 wire harness, which I will be connecting up to the ESC, and then we are going to be wiring the 4 signal wires to each respective signal pad on the flight controller board. Since we have our LiPo connected directly to the flight controller board, and it has a 5-volt regulator that's powering the flight controller board, we need to remove the 5-volt wire coming from the 4-in-1 ESC, because we don't need that anymore. Let's just connect this to our 4-in-1 ESC so that we can measure up the wires. So we have our black ground pin and the 4 other signal pins, and we need to route them up to each of their respective pads. So motor signal wire 1 is over to the right and 2 is over to the left, and we need to cut our wires to just enough to reach those pads. And then here we are soldering the ground and all of the signal wires to their respective pads. Alright, thank you for watching, and if you found this video useful, click on the like button and hit subscribe. And I'm gonna also show you a link to my Patreon page, and we have a lot of projects coming up, a lot of ambitious projects coming up. We're coming up with a STEM course. We're going not just up in the air but down underwater. So there's a lot of projects that I want to do, and all of the support that I can get would really help in getting those projects off the ground. So until next time, keep building and keep flying.